Hello everyone, in this video I'm going to discuss the axiomatic definition of area. So we have two important definitions before we start. The first one is a measurable set. What is a measurable set? It is a set that we can assign an area to it. For example, it could be a rectangle, a triangle, whatever. And the second definition is a set function. It is a function whose inputs are sets. Now assume that there exists a collection M of measurable sets in the plane, and a set function A whose domain is M, which is the collection of measurable sets, with the following 6 axioms. So we have 6 axioms. So the first axiom is the non-negative property, which says for each set S in M, which is a collection of measurable sets, we have A of S is greater than or equal to 0. This means that the set cannot have negative values. And now we have the second axiom, which is called the additive property. If S and T are in M, which means that if S and T are measurable, then S union T and S intersection T are also measurable, which means that they are in M. And we have the area of S union T is equal to area of S plus area of T minus the overlap minus area of S intersection T. So now this is the third axiom, which is the difference property, which states if S and T are in M, which means that S and T are measurable sets, with S is a subset of T, then T minus S is also measurable, and we have area of T minus S is equal to area of T minus area of S. And this is the fourth axiom, which states, its name is invariance under congruence, which states if a set S is in M, which means that the set S is measurable, and if T is congruent to S, then T is also in M, which means that T is also measurable, and we have the area of S is equal to the area of T. And now this is the fifth axiom, which its name is choice of scale. It states that every rectangle R is in M, which means that every rectangle is measurable, which means that we can assign area to any rectangle. And if the rectangle has length L and width W, then the area of the rectangle is length times width. And finally, we have the sixth axiom, which is called the exhaustion property. Let Q be a set that can be enclosed between two step regions. Step regions means that it's a set in the plane formed by putting together finite number of rectangles by two step regions S and T, so that Q is a subset of T and S is a subset of Q. So if there is a number C which satisfies the inequalities, area of S is less than or equal to C, which is less than or equal to area of T, for all step regions S and T, satisfying this, then Q is measurable and the area of Q is equal to C. And these are all the 6 axioms of area. So now I have arrived at the end of the video. If you guys have any questions regarding this video, please leave them down below in the comment section. And that's it.